Welcome back. This is Mrs. RRubright with Advanced Geometry. Today's lesson is 10.4, Use Inscribed Angles and Polygons. Find the indicated measure of circle P. In circle P. Alright, so the measure of angle T. What is the measure of angle T? So if this arc over here is 48 degrees, what is this angle right here? Well, yesterday we learned that the central angle that opens up to this arc would be the same as it, right? If the central angle is 48 degrees, then the arc is 48 degrees. But now this one's dealing with, instead of the central angle, an angle whose vertex is on the perimeter of the circle, on the circumference of the circle. So, what is my rule here? You guys copied this in the copy for your notebooks. What's my rule? It is half of it. So if this is 48, then this is 24. So if this is 50, what is QT? QT is 100. All right, so angle T is 24 degrees. QR. Okay, well, if this is 100, then what is QR? Here's my diameter. That's my hint for you guys. It is 80. Good job. He has 180. All right. Find the measure of arc RS and the measure of angle STR. What do you notice about the angle STR and angle RUS? All right, so first, they want to know arc RS. All right, well, arc RS is going to be what? What is arc RS? Anybody? I heard it. I heard 62. Because double 31 is 62. What about the measure of angle STR? STR. So let's look at that. What is the measure of angle STR? It is 31, correct. It's 31 because if this is 62, then the angle that opens up to it should be half that, 31 degrees. What do you notice about angle STR, this angle right here, and angle RUS? What do you notice about these two angles? They're congruent because they both open up to the same arc. Name two pairs of congruent angles in the figure. All right, JKM, JKM, and KJL, KJL. Are those congruent arcs? How do you know? You don't know. Let's look at the next one. So how about JLM, JLM, and KLJ, or sorry, KJL, KJL. We're talking about this arc and this arc. We don't know. So this one we have no idea. JKM, JKM, and JLM, JLM. They both open up to the same JM, right? JKM and JLM both open up to the same arc. They are totally congruent. Let's look at the second part of this. the second line says KJL, which is opening up to this arc right here, and KML. They both open up to the same arc. They are congruent. See? Make sense? You see how they're both opening up to the same arc? This angle right here and this angle right here are congruent because they both open up to here. Find the measure of the red arc or angle. What angle is this? What? I did hear the right answer, 45 degrees, because it's half of the arc that it opens up to since it's on the perimeter of the circle. How about here? $76, correct. Find the measure of this angle right here. It is 72, because if this 72-degree angle opens up to this arc, which would be 144, then this angle that also opens up to 144 has to also be 72. Your camera has a 90-degree field of vision. You want to photograph the front of the statue. You move to a spot where the statue is the only thing captured in your picture as shown. You want to change your position. Where else can you stand so that the statue is perfectly framed this way? Anybody know? This is kind of like, if this is your center, yeah, that's not, actually, so it's kind of like this, where if you had a circle from here, any point on this line, on here, that's going to make a right triangle with this. Does that make sense? So anywhere, and it'll make more sense when I show you the picture that they drew. So like here would make a right triangle, here would make a right triangle, here would make a right triangle. So anywhere on this curve, on this semicircle, that's going to perfectly frame this picture. Circles are so important in your everyday lives, and you guys don't even realize it because it's just like human nature. You know, you just kind of move around until it's like lined up perfectly, and you're kind of moving in that arc without even realizing it. You do these things just like, you know, it's just part of human nature. You don't realize the math behind what you guys do on a regular basis, even when you're Snapchatting. All right, so what is the value of each variable? I want you guys to try this with your table partner. So please pause the video, attempt this problem, and then we'll go through it. All right, guys, so this angle right here, angle PQR, is 80 degrees. And the arc that it's opening up to must be 160. Over here, we have QPS as 75 degrees. So it's opening up to 150. Is that going to help me at all? a little bit. Look here. So if we're looking at this right here, being 160, and we can kind of think of it like this. No, we can't because it's not 180. But we can. Okay. Now, don't think of it as a semicircle. Just think of it as splitting it up, right? Into that's 160, therefore, over here must be what? 360 minus 160 is what? 200. 200 plus 160 is 360. So if this is 200, well then isn't the angle across from it half that? 100, right? Do you guys see how I did that? That's why the rule I'm about to tell you works. Okay? The fact that this opens up to 160, therefore leaving this with 200s, that's 100. Now look at this without doing all this. So that's how you can do it if you completely forget rules. You can always prove it. There's always multiple ways to do things in math. So now listen to this rule. If you have a quadrilateral inscribed in a circle, opposite angles are supplementary. 80 plus what is 180? 80 plus 100. Well, why does this work? Because 100 is 200, 80 is 160. The outside of the circle ends up being double. So 180 doubled is 360, and that's why this works. That's why it's half of 360. Angles opposite each other are supplementary. So with that being said, if this is 75, the angle opposite it has to be what? 105. And that's how you can do it quickly. But now you know why it works. Make sense? Do you guys see why it works? Does everyone visualize this? That 80 opens up to 160. So this remaining portion of the circle over here would be 200. So opposite of the 200 would be, what opens up to 200 would be 100. These are supplementary. Opposite angles in a quadrilateral that's inscribed in a circle will always be supplementary. So since they will always, always, always be supplementary, that means that 2a plus 2a has to equal what? 180. So if 4a equals 180, then what? A has to equal 45. So 45 times 2 is 90. They're 90 each. Well, that makes sense, right? Because if they're both the same thing and they both add up to 180, well, then they're both half that, which is 90. 4b and 2b. 6b equals 180. 180 divided by 6. B is 30. So we're going to have 60. 30 times 2 are 60. And 30 times 4, 120. A is 45. B is 30. All right, so on this one, 68 plus what is 180? What plus 82 is 180? 180 minus 82? 98. Try this one. I'm going to pause the video so you guys have a minute to try it. All right, so let's check this out. So C and 2C minus 6 are opposite each other. So those are going to be supplementary. C plus 2C is 3C minus 6 has to equal 180. 186, because we add 6 to both sides, equals 3C. Divide by 3 on both sides, and we get 3 goes into 18 6 times. 3 goes into 6 twice, 62. C is 62 degrees. All right, so we found what C is. What about X? X is going to be 8X plus 10X, or 18X equals 180. Divide by 18 on both sides, and X is 10. So C is 62, X is 10. And that is everything for today's lesson. So we hope you enjoyed our lesson on 10.4, use inscribed angles and polygons. Like our video and subscribe for more videos just like this one. Have a great day.